Madhura ma'am, we will start the session.
Okay, sir. A very good morning to all for today's first session on Empowering Minds for UGC NET, a comprehensive program designed to prepare you for one of the most significant milestones in our academic career. First and foremost, I would like to welcome our resource person, Dr. Abhinandan Kulal, for today's session on the topic Business Statistics and Research Aptitude. It's my pleasure to introduce to today's resource person, Dr. Abhinandan Kulal. Dr. Abhinandan Kulal is a distinguished academic and accomplished researcher, currently serving as a research associate at Anapoya University. With a robust educational background, Dr. Kulal has demonstrated exceptional proficiency in financial accounting, having secured a gold medal from the Institute of Chartered Accountants of India, ICAI. He holds a Master of MCom degree from Mangalore University, where he also earned his PhD title, Saving an Investment Pattern of College Teachers Working in Jurisdiction of Mangalore University, conducted under the esteemed guidance of Dr. Yatish Kumar. His scholarly contributions are substantial, with over 25 research articles published in various prestigious national and international journals, including those listed by the Australian Business Deans Council, ABDC. His research excellence has been recognized through several accolades, includes the Best Paper Award from the Asian Association of Open Universities Journal during the international conference held in Sri Lanka, and an International Research Award from ICAI. In addition to this academic and research endeavors, Dr. Kulal is an active reviewer for the several esteemed publications, including Multicultural Education of Emerald, Bilingual Publications of Singapore, and the American Journal of Applied Science and the American Journal of Business Administration. His commitment to academic excellence is further evidenced by his impressive 12th rank in the assistant professor exam conducted by the Karnataka Examination Authority, KEA. Dr. Kulal's extensive experience and remarkable achievement make him a valuable resource person, contributing significantly to the field of behavioral finance and educational research. On behalf of Refine, I welcome you, sir. I also extend a warm welcome to all the participants who are joining us through the online mode. I welcome you all. I request our resource persons to take over the session now.
Thank you. Good morning for all. I welcome you to for this session on the subject of business statistics and research aptitude. Uh, First of all, I want to I will maximize the screen. Okay, I hope my voice is audible and the screen is visible now.
Yes, sir.
Correct? Yes. You know that in UGC Net Commerce and Management, there is one subject called Business Statistics and Research Aptitude. From this subject, you can expect 10 questions. Each unit has a very important, significant for the net and JRF. Uh, First, I want to tell you whenever you prepare for the NET exam or KSET exams, first buy study material, have a separate study material for you, and write a note on the write uh, points from the readings and keep separate journal for that. So I'll suggest there is one YouTube channel is there, that is Ever Study Class. They have wonderful study materials. You can purchase these study materials from their website, or they have YouTube channel where you can find n number of videos related to NET of commerce and management. So for my NET exams and as well as my uh, KE exams for assistant professor exam, I referred this particular YouTube channel. They're good actually. They have well depth knowledge about the subject, and the delivery of the subject knowledge is very good. So I suggest you to go to Ever Study Class YouTube channel, where you can find revision series, can find 5 minutes explanation about one topic. That is the best one. For the last minute, you can go to that, and you can go to that. Sorry, voice is audible. No, there is no disturbance.
No, sir. You
Okay.
can continue.
So I'll suggest have a material separate study material, and you can search in your study classes and go to the videos. Now we'll jump into today's class. Uh, Today I'll going to cover 10 on measure of central tendency. So there are both statistics and research. First five are the statistics part, and the next five parts are research aptitude part. So very simple actually. Statistic, when you heard the term statistics, you feel a little difficult, but here they don't ask advanced question related to statistics, only the basic question they will ask. So study the basic questions. And research aptitude, of course, again here also you can expect some basic questions from the research aptitude, not advanced level. So first concept or first unit is measure of central tendency. So you know that measure of central tendency are used in statistical subject or in research. Normally, it are used to explain uh, the mean or the average of the data. So if there is large data set, if we want to find out the trend, or if we want to understand the data set, we should have one value. From that we can inference the nature of the data. For that purpose we use central tendency. So in central tendency, there are two types of central tendency. One is mathematical averages, another one positional averages. You should know What are the mathematical averages and what are the positional averages? Mathematical averages means it involves the computation, mathematical calculation required to find out the values. So in mathematical averages, we have arithmetic mean, geometric mean, and harmonic mean. And in positional averages, we have median and mode. So here in measure of central tendency like mean, median, mode, arithmetic mean, geometric mean, harmonic mean, the question you
Excuse me,
can,
sir.
yes,
So your slides are not moving.
slide not visible. Now,
Slides is visible. Okay. Okay, sir. No problem.
okay, mathematical averages and positional averages. So here, what questions you can expect from the central tendency? The first thing you can expect, uh, what are the mathematical averages and what are the positional averages? They may ask. And the properties, very important is properties. You should know about the properties of each central tendency, like arithmetic, the properties of arithmetic mean, the properties of geometric mean, the properties of harmonic mean, and everything. And the next one, you should know the formula. Very important. Here, very important is one is properties and another one the formula. You should know the formulas of everything. So here, when we go for calculation of central tendency, what are the essential? So we can call it as a good central tendency. First one, it should be easy to understand, it should be easy to compute, and it should be unique. Whenever you calculate the value of mean, you should get only one value, unique. It is completely unique than other values, and it has a further treatment, because whenever you go for inferential analysis, from the descriptive you jump to inferential analysis, you need further treatment of that mean, median, and mode. And it should not be affected by extreme values, very important. You know what happens if the observation have extreme values, and it will be affected by the those extreme values. For example, if there are five value, 10, 20, 30, 40, and 150. So here, what is the extreme value? Extreme value is 150 when compared to other four values, which are normal in range, but this 150 is above the range. So that is called extreme values. So what happens if the observation have the extreme values? It will affect the mean value. It does not give true mean or true central tendency of the data. Therefore, the essential requirement to call it as a good central tendency, it should not be affected by extreme values. And you know what, how to calculate the mean. Mean is nothing but sum of observation divided by number of observation, or sum of effects divided by n. So if anyone asks how to find out mean, just total the all the observation and divided by number of observation. So you'll get the mean value. That is very simple. You all know that how to calculate the mean. Next are properties. So what are the properties of mean? The first properties of mean, the sum of deviation is zero. This is, you know, that if you have calculated regression or correlation, we have come across sum of deviation. Sum of deviation is nothing but x minus x bar. The sum of x minus x bar always zero. It should be zero. Sum of x minus x bar. That means the deviation from the mean. So that should be 0, and sum of square deviation is least. So in regression, we have least square method where we apply this concept, sum of square deviation. That is means x minus x bar whole square should be minimum. Sum of square deviation is least. That is x minus x bar whole square should be minimum and affected by change of origin or scale. So mean calculation, the third properties is mean calculation is affected by change of origin and scale. Both it will be affected by change of origin and scale. First understand this concept because it is very important. In every exam you can expect one statement related to this. What do you mean by affected by change of origin and affected by change of scale? For example, if there is observation like 2, 8, 6, 5, so this is the numbers are there. What is the change of origin? Change of origin means if I deduct or add something to the observed values, so does it change the mean value? Yes. When you deduct, for example, if you deduct 1 from the given values, the mean value will change. And what is the change of scale? If you multiply or if you divide any number, constant number, to the observation, does it change the mean value? Of course. If you, for example, for 2, if you multiply 10, for 5, if you multiply 10, if for 7, if you multiply 10, the mean value will change. Correct? So that's why the mean value is affected by change of origin as well as scale. So you have to remember, they sometimes they will ask whether mean value is affected by change of origin or scale. You should know that. And it is rigidly defined. So why it is rigidly defined? Means if any person calculate by taking same observation, calculate the mean value, so every person has to get same value. From the same observation, different person calculate the mean value has to get same. So there is no difference in the value unless otherwise there is a calculation error. So they will get all will get same value. So therefore it is called rigidly defined. So there is one concept called weighted mean. So weighted means here we give some preference or we give more weights for some values compared to other values. So that is called weighted mean. If you know the concept of Sensex or Nifty, so in the Nifty calculation, they give some weightage based on the market capitalization. Of course, they do not find out simple mean there. They find out weighted mean. They will give more weights to those companies which have more capital compared to low capital. So that is called weighted mean. And you know how to find out weighted mean. The formula is given: n1 into x1. X1 is nothing but weights, plus n2 into x2, that is the weight for the number 2, divided by n1 plus n2. So you'll get out the sum of weights. So that is the properties of the mean. Next, demerits. What are the demerits of the means? So can't compute for qualitative data and affected by the extremes. So here, uh, mean can be calculated only for quantitative data, means which can be quantifiable, which can be measured in numbers. For example, weights, heights, which can be measured in the weight, the mean value of height. But we cannot compute the mean value of human behavior. For example, attitude. It is a qualitative aspect. Angerness. Angerness, what is the mean of average of angerness? We don't know. It is a qualitative term. Of course, in research, we have method to convert qualitative data into quantifiable measure by using Likert scale or scale. But mean, we cannot use it for qualitative data. And mean is affected by extremes. You know that I already explained. The normally mean will be affected by extreme. If, for example, the values are 10, 20, 30, 40, and 150, the average will be different, because 150 is too extreme. If you compute the average of these five values, you will get a pseudo mean. It is not actual mean, it is not true mean, but you get pseudo mean. It is not proper mean. So it is affected by the extremes. Next one, we have geometric mean. You know that geometric mean will be calculated by nth square of square root of the sum of, sorry, product of all the variables. N square root of x1, x2, x3, we have to multiply. Or the other formula, anti-log of sum of log x divided by n. So if you find difficult to find the geometric mean using, for example, if there are 15 values or if there are 20 values, so it is difficult to find out the product as well as the square root. We have to take a square. But you can use another formula, anti-log of sum of log x divided by n. Here, first thing we have to take the log of individual values, then find out the sum of it divided by number of observation. So that is geometric mean. So here you have to remember the formula. Formula you should know. The formula. You write down the formulas somewhere else separately and read out. At least one question you can expect from formulas by asking which which one is the correct formula for given harmonic mean, geometric mean. The formula is very important. Then what is the properties of geometric mean? So if all the observations same, geometric mean also same. You know the concept of geometric mean. We take the product and take the square. So if all the value are same, means 2, 2, 2, 2, then what is the formula? 2 into 2 into 2 into 2. We have to take 4 square. 4 square. Same value, you will get 2 only. So therefore, if all observations same, geometric also same. And if z is equal to x into y, then geometric mean of z is equal to gm of x into gm of y. For example, if there are three series x, y, and z, x separately independent, y is independent, and but z, if the product of x into y, then the mean of y.
Excuse me,
You can
sir.
calculate that.
Excuse me, sir.
Yes.
Sir, your voice is breaking little bit and your screen. Okay, now the screen has been changed. It's not in a presentation mode, I guess, sir. Can you make it in a presentation mode?
Yeah, I'm teaching this one. No?
Yes. Now it is changed. Earlier it was a first slide.
Only,
Okay.
okay, okay. I think if I do full screen, it will
Yeah.
not move.
Okay. Okay. So next screen.
Okay, okay. Now it moved.
No, sir. It is in the fourth slide only. Actually, you are in fourth slide. Now you are in fifth slide. Geometric mean and
Okay, okay. Is it visible? The words are visible now?
yes, sir. Words are visible.
Visible, no problem. No,
Okay.
I
Kindly
will
make sure
zoom it.
that slides are moving, sir.
I'll zoom it.
Okay.
Now, good. Okay.
Yes, sir.
So geometric mean, the properties, as I explained, if any observation is zero or negative, we cannot calculate geometric mean, because you know that if you multiply any value to the zero, this product will be zero. So therefore, if any observation is either zero or negative, the logarithm of geometric mean is the arithmetic mean of the logarithms of the given values. So this is the properties of geometric mean you should remember. Then what are the uses of geometric mean? Very important. Sometime they will ask x numbers, population growth rate, where the data in rates, ratio or percentage. Sometimes they will ask to find out average. If the observation are given in percentage, we cannot use mean. Mean does not give proper value. So at that time, we have to use geometric mean. Understood? So this means we can use geometric mean to find out average of rates, ratio and percentage. Next one, harmonic mean, another uh, uh, mean, that is the reciprocal of the arithmetic mean of the reciprocal of the individual values. How to find out arithmetic mean? 1 divided by individual value. 1 divided by bracket 1 divided by individual value. Reciprocal. So that is called reciprocal. Reciprocal of the arithmetic mean of the reciprocal of the individual values. So when we can use harmonic mean? Average rate like kilometer per hour, per day items manufactured. So whenever per day, per kilometer, per liter, kilometer per hour, this kind of units are used to measure the variable, then we have to use harmonic mean. And we cannot calculate if any of the observation, we cannot calculate the harmonic mean if any of the observation is zero or negative. And there is one important concept you should know. Arithmetic mean is larger than geometric mean, and harmonic mean is smaller, then geometric mean is little larger, and arithmetic mean is larger than both geometric mean and harmonic mean. And if there are two observation, only two observation, then we can calculate geometric mean by square root of arithmetic mean into harmonic mean. Please remember this formula. Sometimes they will ask the question. For example, they will give arithmetic is so much, harmonic mean is so much, find out geometric mean. So at that time, you should know how to find out geometric mean by when they give arithmetic mean and harmonic mean. Next one. So there is one question. One question is there. Which of the following are the measure of central tendency or measure of location? Measure of location, also called for central tendency, we also call a measure of location. For example, mood is the measure of location. So central tendency, which among the following are the measure of central tendency or the measure of location? So which one asked in the examination? So we already discussed central tendency. Here the mean is central tendency, mode is central tendency, median is central tendency. Range and variance are measure of dispersion, not central tendency. So therefore the answer will be A, C, D. ACD. That is the third option. Third option will be the answer. Next one. Next question. An economy grow at 5%, 12%, and 7% over the last 3 years. The average annual increase over this period would be. So normally you know that harmonic mean, geometric mean, and arithmetic mean. So when the percentage is given, we need to normally we have to go for geometric mean. And geometric mean is lesser than arithmetic mean. So first find out arithmetic mean of this values. 5 plus 12 plus 7 divided by 3. 17 plus 7, 24 divided by 3. 8 divided by 3. So arithmetic mean is here the percentage is given. For percentage we need to find out geometric mean. And we know that geometric mean is less than arithmetic mean. So therefore 8% or less. The first option, 8% or less, will be the correct answer. Next, measure of dispersion. So just using central tendency, we cannot describe the data. Just by having mean value, we cannot describe the nature of the data. So we need measure of dispersion, we need variance, we need standard deviation to explain more about the data. So what do you mean by measure of dispersion? Measure of dispersion means degree to which numerical data tend to spread about an average value. So how data is spread from the mean value? If you take mean value as a central, how observed values spread around the mean value? How the degree, the extent, how extent it spread around mean value. So that is called measure of dispersion. And what is the purpose of or objectives of measure of dispersion? To test the reliability of average, compare variability in two or more distribution, computing other statistical measure like correlation, regression, basis for control of variation. So to test the reliability average, so it will give you the average. If the dispersion is more, that means that average is not reliable. If the dispersion is less, that means we can rely on that average. And we can compare variability in two or more distribution. For example, if you are comparing two samples and you get the mean value, got the mean value same 2.5, 2.5. Now I want to compare which one is better. So at that time, we have to look the variability or dispersion. The lesser dispersion is more close to the mean value. And computing other statistical measure like correlation, regression, basis for control variation. So it will be used to calculate correlation and regression. When you calculate the correlation and regression, dispersion is very important. X minus x bar whole square or x minus x bar. So this concept will come when you calculate the regression and correlation. And when we can call it as good measure of dispersion, it is easy to calculate, easy to understand, rigidly defined, based on all observation, taking consider all the observation. Further mathematical treatment should be there, not unduly affected by extreme observation. It should not be affected by extreme observation. So these are the parameter for good measure of dispersion. And in measure of dispersion, there are two types. One is absolute measure and another one relative measure. So absolute measure, we how to remember which one is absolute measure and which one is relative measure. Absolute measure, you directly calculate the values. One formula will be there. So directly you can only one in simple only one formula will be there. But relative measures we have two or more formulas to find out that. So in absolute measure, we have range, quartile deviation, mean deviation, and standard deviation. The first thing you should know the concept of range, how to find out range. See, range is nothing but large value minus small value. Large value and small value. The difference of large value and small value in the series is called range. For example, 2, 5, 10, 15, 50. Here 50 is the largest value and lowest value is 2. So 50 minus 2, 48 will be the range. And if you want to find out coefficient of range, then large value minus small value divided by large value plus small value. Uh, 50 minus 2 divided by 52. So that will be coefficient of range. Next, properties. So properties of every concept is very important. From that dispersion, unaffected by the frequencies. How many times data is repeated is not matter to find out measure of dispersion. And it is independent of origin but not scale. So it is unaffected by the frequencies, repetition, and independent of origin but not scale. If you add, deduct one constant number to the observation, measure of dispersion will not change. But if you multiply and divide a constant number to the observation, the measure of dispersion will change. So very important, remember, measure of dispersion is independent of origin but not scale. Next, demerits are not based on all observation, affected by extreme observation, not suitable for algebraic treatment, cannot be calculated for distribution with open ends. So not based on all observation. For example, range. Range we cannot consider, we do not consider in range, we do not consider all observation. We consider only largest value and smallest value. And affected by extreme observation. In the given example, 50 is extreme observation. So therefore you get a pseudo range. not actual range, but get pseudo range for the observation, and not suitable for algebraic treatment. From the range we can draw inference. So this is the lowest value, this is the highest value, so this is the interval, but we cannot go further algebraic equation or further algebraic treatment. Only range is done. Once you calculate range, that's done. You cannot use range for any other further calculation. So that is the demerits of range. Next one, quartile deviation. You know that quartile deviation, we call it as quarter. In a year we have quarter, divided entire year into three parts, Q1, Q2, Q3. So that is the quartile or semi interquartile range. The formula to find out quartile deviation is quartile 3 minus quartile 1 divided by 2. Very simple. Q3 minus Q1 divided by 2. So that will be quartile deviation. Next one, coefficient of quartile deviation is equal to, say, similar to range, Q3 minus Q1 divided by Q3 plus Q1. And the properties of quartile deviation is, it is independent of extreme values and best for open-ended distribution and independent of change of origin, but not scale. So the properties of any quartile deviation will be same for the same for measure of dispersion. Whatever we discussed, the properties of measure of dispersion will be applicable for all the measure of dispersion. And for symmetrical distribution, we should know the what is the concept of symmetrical distribution. Bell-shaped curve. We studied normal distribution on the bell-shaped curve. So that concept is called symmetrical distribution. So in the symmetrical distribution, Q3 minus median is equal to median minus Q1. When the data is quartile 3 minus median is equal to median minus Q1. And also Q2 is equal to Q1 plus Q3 divided by 2. Remember, only when symmetrical distribution, when we have symmetrical distribution, we can find out Q2 by using Q1 plus Q3 divided by 2. And if Q3 minus median is more than median minus Q1, means not equal, but the Q3 minus median positively skewed curve. There is one more concept, skewness. So with the help of this formula, we find out whether it is positively skewed or whether it is negatively skewed. If Q3 minus median is more than median minus Q1, so that means positively skewed. And if Q3 minus median less than median minus Q1, that means negatively skewed. Folded. So that is called skewness. So that concept we are going to next slides. Now, what are the demerits of the quartile deviation? Based only middle part, not capable of treating mathematically. See, in quartile deviation, we remove first 25% and we remove last 25%. We remove, whenever you go for the calculation, we remove the first 25% and remove the last 25%. So we consider only mid 50%. So that is the biggest demerits of quartile deviation. And mean deviation, arithmetic mean of absolute deviation, observation from central value like mean, median or mode. So mean deviation is nothing but arithmetic mean of absolute deviation of observation from central values. The difference from the observation value and mean value is called mean deviation. Then what are the merits of uh, mean deviation? Based on all observation, less affected by extreme observation, easy to understand and easy to compute, not much affected by fluctuation sampling. So here we take all the observation, less affected by extreme observation because we remove it, easy to understand and easy to compute, not much affected by fluctuation of sampling because we eliminate the extremes. Then demerits. So demerits of measure of dispersion under quartile deviation, algebraic science ignored, maybe not given accurate result, no further treatment. So whenever you calculate the mean deviation, we ignore the sign. See, x minus x bar, you know that sum of x minus x bar always 0. Therefore, here we ignore the sign to find out the mean deviation. Mean deviation is nothing but sum of x minus x bar divided by n by ignoring sign. So here we ignore the sign, but so that is the one limitation of mean deviation and no further treatment. Only mean deviation, you calculate mean deviation and take an inference analysis. You can go for inference analysis, then done. No further mathematical computation or algebraic equation. So that is the limitation. Next one, standard deviation, very important. The variance in the average sum of square, the sum of square divided by number of observation, the standard deviation is the square root of the variance. So what is the formula for standard deviation? You should know. When you understand the formula, you will understand the concept. X minus sum of x minus x bar, the square root of x minus x bar whole square divided by n. So what is variance? Variance is nothing but sum of x minus x bar whole square. So that is the variance. When you take the square root of the variance, you will get the standard deviation. Then what is the properties of the standard deviation? So not less than mean deviation from mean and independent of change of origin but dependent on change of scale, same like range. Combined standard deviation can be computed. We can compute combined standard deviation. So here one concept is given, very important. Quartile deviation is 2/3 of standard deviation and mean deviation is 4/5 of standard deviation. Remember this one. Quartile deviation is 2/3 of standard deviation and mean deviation is 4/5 of standard deviation. So if you calculate standard deviation, then you calculate quartile deviation and you calculate mean deviation. Then coefficient of variation. The formula for coefficient of variation is standard deviation divided by mean into 100. It expressed in percentage. Standard deviation divided by mean into 100. Then standard deviation is best measure, but it difficult to compute. More weight extreme items cannot be used to compare. So this is the limitation of standard deviation. Best measure. It is the best measure, but difficult to compute. Calculation is very difficult. And more weight to extreme items. Extreme items will be considered. Cannot be used to compare the dispersion of the distribution expressed in different units. If, for example, one observation expressed in kgs and another observation expressed in liters, so we cannot compare the standard deviation of first observation and standard deviation of second observation. So that is the limitation of standard deviation. Next one. So there is one question. Given below are two statements. One is labeled as assertion A and other is labeled as reason R. So assertion mean deviation is about 80% of standard deviation. Reason the quartile deviation is about 2/3 of the standard deviation. Now tell me first whether these statements are true or false. Then tell me whether assertion explained by the reason. So mean deviation is about 80% standard deviation. We know that we already discussed. Mean deviation is 2/3 of standard deviation. 2/3 means 80%. Sorry, 4/5 of standard deviation. So 4/5 means 80%. Next, quartile deviation is about 2/3 of standard deviation. So both are true. Both A and are true, but both independent. They are independent statements. So there is no relation. Assertion is not explained by the reason. They are completely independent. So therefore, both A and are true. R is not the correct explanation of A. So that is the second option. Second option is the correct answer. Next question. Which of the following statement is correct? Coefficient of variation is equal to standard deviation of mean into 100. Correct? So that is the correct. We already discussed the formula for variance. Variance is nothing but a standard deviation divided by mean into 100. So that is the correct. Statement. Option 1. Next concept, the distribution, in which side distribution is loaded. Whether it is loaded straight, normal distribution, whether it is loaded left, positive skewed, whether it is loaded right, negatively skewed. So that is skewness means how you can see, look at here the image. So this one is negatively skewed, right side, loaded to the right side. So it is called negatively skewed, and this one is positively skewed because it is loaded to the left side. So positive skewness. So what is skewness? Skewness is nothing but defined as a lack of symmetry. Symmetry will be not there. Normal distribution will not be there. Normal distribution will not be there. So more the mean moves away from the mode, larger the skewness. So very important, remember, more the mean moves away from mode, larger is skewness. If mean value move away from the mode, the skewness will be large. If mean here mean is equal, if mean more than median and median is more than mode, then that distribution is called positively skewed. Distribution is called positively skewed. And if mean is less than median, very important, remember this. Based on this, you can expect question uh, on the skewness, and there is a formula to find out skewness. Carl Pearson given skewness formula, mean minus mode divided by standard deviation, or 3 into mean minus mode median divided by standard deviation. So it lies between -3 and +3. Remember, the skewness lies between -3 and +3. And Bowley's method of skewness is given, and it lies between plus or minus 1. Then Kelly's method of skewness is given, and again it lies between. Kurtosis in Greek means bulginess. In simple word, the peakedness, how peak the distribution is there, based on that kurtosis divided. In kurtosis there are three types of kurtosis: leptokurtic, mesokurtic, and platykurtic. Mesokurtic is normal distribution. If the distribution is symmetric, so then it is called mesokurtic. If the distribution is more peaked than normal, then it is called leptokurtic. You can look at the image. The red line is leptokurtic because it is more peaked. The green one is normal distribution, so that therefore it is called mesokurtic. And the next one, uh, sky blue, is given in a very flat, so that is platykurtic. The and the kurtosis can be measured with the help of moment. The third moment measures skewness, third moment measures skewness, and fourth moment measures kurtosis. Remember, the third moment measures skewness, and fourth moment measure kurtosis. And there is a formula you can find out: moment of third moment square divided by second moment cube. You can find out beta and gamma. There is a formula. And measure of kurtosis, you can find out measure of kurtosis using these formulas. Remember the formula. They don't ask the problems on kurtosis. You just remember the formulas may ask in the examination. See, there is one question: which one of the following summary measure denote the degree of lopsidedness in a distribution? Lopsidedness means what side lopsidedness in a distribution. So you know that I already explained. Which side distribution is loaded is called skewness. So measure of skewness is the correct answer. Next one. If each value in a given set of data is divided by 4, how it will affect Karl Pearson coefficient of skewness? If each value given in data set divided by 4, how will it affect Karl Pearson coefficient of skewness? You know that formula of skewness. So divided by 4. So 1 by 4 and 1 by 4 will be striker. So it will not affect the coefficient of skewness value. The answer will be third. It will not affect the coefficient of skewness value. So there is a need of some calculation. Better work out on this particular problem. Use the formula and divided by 4 for individual. Then you'll understand how the answer is. It will not affect the coefficient of skewness value. Next, correlation and regression is common thing. We studied in our bachelor degree, in our master degree, and even in PhD. This is a very important concept: correlation and regression. So here statistical measure that indicates and analyze the correlation is nothing but it helps to understand the relationship between two or more variable. And there are classification: positive correlation, negative correlation, and no correlation. Positive means if both the variables moves in same direction, it is called positive correlation. if both the variable moves in the opposite direction, then it is called negative correlation. If there is no correlation, means we cannot identify which direction it is moving, so then it is called positive correlation. And if there is correlation, then it is called no correlation. And based on number of variable, we have simple, partial, and multiple correlation. Means correlation between three variable, two or more variable, but keeping one variable as control variable. So that is called partial variable, partial correlation. And multiple correlation, at a time we are simultaneously we are calculating the correlation of two or more variables. Have the assumption of linearity, so then it is called linear correlation. Means when you draw the line, I will get straight line, so that is called linear correlation. If you draw the connect the dots of the observed variable, and if you get curvilinear, then it is called non-linear. So there are different methods are there to measure the correlation. One method is scatter diagram. From the scatter diagram we can see whether it is linear or non-linear. And next, covariance is deviation of two variable x and y from their respective means. And negative means inverse. I think this concept is very simple. You already know. Very important thing you have to remember the formula and the properties of correlation. So very important. One more, the probable error. Probable error. See, in correlation we get point of estimation. Point of estimation means we get single value. A single value r is equal to zero point 0.8, but there will be some error. It may be sampling error or non-sampling error. But if there is error, how to measure that error? So to find out the error in the correlation, we use probable error. The formula of probable error 0.674 into 1 minus r square divided by square root of n, and standard error 1 minus r square divided by square, and probable error is equal to 2/3. Very important. Remember this formula. This is very important. Okay, there is one question asked in the examination. A coefficient of correlation having a value of 0.87 implies that, you know that correlation lies between plus or minus 1. Close to plus 1 means positive correlation, high positive correlation. Close to minus 1 means high negative correlation. And 0 means no correlation. So here 0.87, so that means coefficient of correlation is strong and positive. So we can opt first option, that is coefficient of correlation is strong and positive. So which one of the following is correct? See, the formula of probable error is given. So probable error formula, the options, first option is correct, or second option, option ID 8589 is correct. Probable error is equal to 0.6745 into 1 minus r square divided by square root of n. So that is the correct formula for probable error. Then regression. Regression is very important. Here remember the formula, and remember the properties of the regression. Read or the properties of regression. And there in regression there will be two variable, independent variable and dependent variable. Independent variable also called as regressor, predictor, explanatory variable, and dependent variable also called regressed and explained variable. And regression line is single line that best fits the data. So here we draw two line, one is x on y and y on x, a regression coefficient bxy and a regression coefficient by and x. So we calculate that. We have the formula sum of y is equal to na into beta sum of x, or sum of xy is equal to a sum of x plus beta sum of x square. So by using this equation we can find out alpha, we can find out beta, then we can find out what is the value of y. So this formula you can use to find out regression. So there are two regression coefficient, byx and bxy. The formula, direct formula is there. By using direct formula, you can find out what is the regression coefficient y on x and what is the regression coefficient of x on y. So remember this formula. And very important, from the regression coefficient, from two regression coefficient, you can find out the correlation coefficient. How to find out correlation coefficient? The correlation coefficient is nothing but the square root of product of two regression coefficient, square root of byx into bxy, and is equal to r. And one more thing you have to remember, the sign. The sign of two regression coefficient and correlation coefficient will always be equal. If it is negative, all three are negative. If it is positive, all three are positive. Remember that. So two regression lines always intersect at each other at their mean or average values. So we have two regression line. One is y on x and x on y. When you draw the line y on x and x on y, the intersect point will be the average values. Remember this one. They may ask in true or false section. So the regression line always intersect at their mean or average values. The intersect point will be the average values. Regression coefficient are independent of the change of origin but not scale. Remember, see, correlation is independent of origin and scale, but the regression is independent of origin but not scale. So that is the properties of the regression. So there is one question asked, which one of the following statement is false? So to answer this type of question, you should thorough about the properties of the regression, correlation, standard deviation, everything. I'll suggest to read about the properties of the statistics part. So here regression coefficient are independent of change of origin but not change of scale, correct? Both the regression coefficient cannot assume value greater than 1, correct? Because if one regression coefficient is greater than 1, another should be less than 1. So it is correct. Regression coefficient of the two variables may have different algebraic symbols for real life situation. So this is wrong. We already discussed the regression coefficient, both regression coefficient and correlation coefficient, the symbol, the sign will be same. It will not be different. So that is the false statement. And last one, coefficient of correlation is independent of the change and origin and scale of data, correct? So that is also correct, but third one is wrong. So which one is the false? Third one is the false. Next one, if two regression coefficient are 0.8 and 1.2, which one of the following value of coefficient of correlation value? So now tell me, which one of the how to find out correlation coefficient when two regression coefficient is given? It's very simple. We have to take the square root of 0.8 into 1.2. So I'll calculate. Please calculate what is the value. So 0.8 into 0.12. Use calculator. In simple, or you can use 0.8 into 1.2 is equal to 0.96. The square root of 0.96 will be 0.97. So therefore the answer will be 0.97. Next one, for given set of period of data, the correlation and regression coefficient have been calculated as being equal r bxy and byx respectively. Now each of the values of the x series divided by 5, each of the value of the x series, okay, x series is divided by 5. What effect does it have on each of these coefficient? So you know that correlation coefficient is independent of origin and scale. So that means there is no change in r. But beta of y on x changes to 5bx, and beta xy changes to bxy divided by 5. So therefore the answer will be fourth one. Okay, here we completed with the concept of business statistics. Next one, research aptitude. I think Ajay sir already covered research aptitude. I don't think I again go through detail about concept of research. I'll just give glance and I'll tell you what should you read. And what question you can expect from the uh, research. Understand the meaning of research, what do you mean by research, and what not research. Understand, research is nothing but it is a search of new fact. Research, when you look at the term research, research, search it again. So search for new fact phenomena to gain familiarity and creation of new knowledge, or the use of existing knowledge in new and creative way, and careful, critical, unbiased investigation or problem, structured and systematic inquiry, and highly purposive. And what is not? It is not simple gathering of information, not merely reorganizing, rearranging, or restating it, not merely transportation of facts from one location to another, not playing of words, not sales gimmick. So when we call it quality of good researcher, we you should know what is the qualities of good researcher. He should be creative, analytical mind, sincerity, ability, stay calm, curiosity driven, grasping power, written and verbal communication skill, knowledge of respective subject, familiarity with techniques and tools, familiarity about the information, honest and hard work. And very important, one question definitely you can expect from the research process. Research, you study the steps involved in that order only. Study the steps, and definitely you can expect one question from the research process. So first one, define research problem, review of literature, defining the research gaps, setting up research objective, setting up hypothesis, preparation of research design. So these steps are very important. I think you already know, if you are prepared project in your master degree, or if you are doing PhD, or if you have done project work, you know these steps. Definitely, you have come up through these steps. I think there is no need to explain again. So there is one question related to research process. Arrange the following steps involved in research process to carry out the orderly and systematic research. First one, formulation of hypothesis, collection of. We have to, that first step is defining research problem, that is C. Next one, formulating hypothesis, A. Next one, prepare research design, D. Next, collection and analysis of data, B. And last one, interpretation and reporting data. So second option will be the correct answer. And you can expect questions from the types of research. So there are various types of research: fundamental, applied research, action research. You can expect question from that. And types of research: applied research, action research, uh, exploratory research, descriptive research. Just I'll give this material, you read out this material, read the material, you'll understand what is the concept. And if you have any doubt, you can contact me, you can approach me, I'll definitely clear out the doubts. So these are the types of research. And quantitative and qualitative research. So one question is asked, research carried out expand the knowledge of particular field is known as applied research. See, applied research means there is a practical application will be there. So that is not the answer. Next one, qualitative research is on the qualitative aspects, so it does not the answer. And quantitative also, it has a quantitative aspect. But basic research or pure research or fundamental research is the answer for the main purpose of basic research is to expand knowledge or developing theories, developing principles. So this is the objective of basic research, so that is the answer, option D. Next one, the study of why does stressful living result in a heart attacks can be classified as. So here research question is given. The study of why does stressful living result in a heart attack. You know that descriptive research describe the nature of the research. Explanatory research explains the cause and effect. Correlation research investigate the relationship between the variables. Feasibility research whether that particular research is feasible or not. So here want to know whether stressful living results in heart attack. So here we are looking at the cause and effect. What is the cause? Stressful living. Effect, heart attack. So we are looking at the cause and effect, therefore it is an explanatory research. Then the critical difference between experimental and exposed factor research lies in terms of what is the critical difference. First understand what is experimental. You know that there will be controlled group and uncontrolled group, and there will be a manipulation will be there. We can manipulate the control group. We are completely given freedom to uncontrolled group. And exposed to factor research is nothing but if event is happened, and after that we go and conduct research. For example, war in Ukraine. So if we want to know the life situation of the Ukraine people, so after post war, so that is called exposed to facto. So there is no manipulation, there is no control on the variable. So therefore the answer will be control and manipulation of independent variable is the answer. Data collection and classification of data. You know that we can collect primary data and secondary data. Primary data directly collected from the respondent, and secondary data already published data. And in so this is the two types of data collection and classification is you can expect some questions from this data collection and classification of data. So I'll suggest don't leave research aptitude, because research aptitude will be asked in both first paper 1 and paper 2. So if you read one time, you will get the benefit of 2. Even in first paper there is a research aptitude, and even in second paper also research aptitude is there. So there is one question, which of the following not source of secondary data? This is very simple question. I interview, you know that that is the primary data directly collecting from the respondent. Questionnaire also primary data directly distributing questionnaire to the respondent and collect the information. Observation also primary data. We observe the variables and get the information. Unpublished thesis. So that is the secondary source. And annual report also already published resource, that is annual sorry, secondary data. So here the question is which of the following are not sources of secondary data, means which are the primary data. Primary data: interview, questionnaire, observation, ABC. So answer will be 4. Remember this formula, the Sturge rule for determine number of classes in a frequency distribution. What is the formula for Sturge rules for determining the number of classes in frequency distribution? As n is equal to, the option will be n is equal C, that is n is equal to 1 plus 3.3 log n. Option C, n is equal to 1 plus 3.3 log n. There are level of measurement. You can expect one question from level of measurement. There are four types of scale measurement: nominal scale, ordinal scale, interval scale, and ratio scale. Uh, I explained while discussing qualitative data. Qualitative data cannot be expressed in cannot be expressed in quantitative term, but there are some scale which help us to convert that qualitative data into quantitative manner. So these are the scale. Nominal scale. Nominal scale. You read the meaning of nominal scale and example. Meaning and example, very important. Meaning and example, they will ask either through example or through meaning. So ordinal scale, interval scale, and ratio scale. So there is one question asked: the scale of measurement which has no order, distance, unique origin is known as which one of the following? No order, no distance, no unique. Just for the purpose of identification, we divide the sample, or we divide the individual into different groups. So that is basically the meaning of nominal scale. So the answer of this question will be nominal scale. And concept of sampling, you know that in research there will be two concepts. One is population, another one is sample. Population is entire population of our research. It is very difficult to collect the data from entire population, so therefore we go for sample. We pick some part of the population for data collection purpose. That is called sampling. Sampling is a process or techniques of selecting some individual members or subset of the population. And census method, data is to be collected from each member of the population. Census method, but the census is different because from each member of the population we have to collect the data. And population, the meaning of population, entire group that you want to draw conclusion about measurable character is called parameter. In research, there is a misconception that population means entire population of the India. For example, if your study is conducting in India, it not right, because in research population means population of your study. For example, if my thesis is related to savings and investment pattern of college teacher in Mangalore University jurisdiction, so I have to collect the my population is college teacher who are working in the Mangalore University, not college teacher working in entire India or entire world. My population is restricted to my study, so remember that. And sample is subgroup or fraction of population. Measurable characteristics is called statistics. So measurable characteristics of population is parameter. Remember, measurable characteristics of the population is a parameter, and measurable characteristics of uh, sample is called statistics. And sampling process, how the sampling will be selected. First, define the target population, develop sampling frame, select sampling method, determine sample size, execute sampling process. So everything. So these are the sampling. And sampling distribution. Sampling distribution is nothing but uh, if I pick 10 samples from the total population and find out the mean and represent that mean in the chart or in diagram, so that distribution is called sampling distribution. So there are central limit theorem is there. Central limit theorem is says that if the population is not normally distributed but the sample size is sufficiently large, then sample means will be have approximately normal distribution. That means if the population is not normally distributed but you have taken large number of sample size, so your distribution will approximately it become normal distribution. If the sample is distributed, but if you have taken small sample size, so there is no guarantee that data is normally distributed. So there is one question is there. A statistic is characteristics. Statement one: a statistic is a characteristics of population. It is wrong, because you know that statistic is characteristics of sample. The characteristics of population is parameter. So that is the wrong. Statement one is wrong. The standard error of mean is the standard deviation of sampling distribution. Standard error mean is standard deviation of the sampling distribution. Correct? That is correct. Standard error of mean is the standard deviation of the sampling distribution. Correct. The standard error of mean decreases in direct proportion to sample size. That also correct. The standard error of mean decreases in direct proportion to sample size. If you increase the sample size, the standard error will be decreases. So answer will be only 2 and 3 are true. B. Next question. Which one of the following tenets is not correct in the context of central limit theorem? Which one of the following tenets is not correct in the context of central limit theorem? If the population from which a sample is drawn normally distribute, the sampling distribution of mean will be normal for all sample size. If population from which sample is drawn normally distributed, the sampling distribution of mean will be normal for all sample size. Correct. That is correct. The population is normally distributed, and if you take any sample size, that will be normally distributed. The mean of the standard deviation population of mean, that also correct. Mean of the sample distribution mean is the population mean. Correct. If the population is not normal from which sample drawn, the sample distribution mean is not normal for any sample size. Wrong, because if the sample size increases, it will be normally distributed, so it is wrong. If the population is not normal from which sample is drawn, this appropriate normal as the sample size increases. If the That is correct. So which one is wrong? C. C is wrong. If the population not normal from which sample drawn, simple any size. And next one, sampling method. Sampling method is very important. There are some questions will ask based on sampling method. Read as much as sampling method. So I list out some sampling method. There are other sampling methods are also there. You read read the meaning and the process. uh, for example, what is the judgmental sampling and how the sample will be picked under judgmental sampling. That concept you have to read for the examination. Convenience sampling, what is convenience sampling and how it is processed. And if you have the time, you can read out the merits and demerits of the each sampling method or sampling techniques. So there will be probability sampling technique and non-probability sampling technique. Divide probability sampling technique and non-probability sampling technique. See, the first category is non-probability sampling technique, and second category is probability sampling technique, or random or non-random sampling technique. You study what are the random sampling technique, what are the non-random sampling technique, and read the meaning of the each sampling technique and the process of picking sampling, and the merits and demerits is very important. So there is one question. Respondents of recent sample survey provided names of friends they thought they would be likely user of new product. These friends were conducted completed survey and asked to supply name of their likely user. Which method of sampling has been used in the survey? Here, for example, I contact 5 persons and I'll ask those 5 person to refer any other 5 people for as a sample. So this is nothing but snowball sampling. So the sample size will become bigger and bigger after each references. So snowball sampling. Next question. Match the item 1 with match 2. So purposive sampling. What is the purposive sampling? Purposive sampling is researcher relies on his or own judgment when choosing members from the population. So for A, the 2 answer for A 2. Next, multi-stage sampling. That is one dividing the population into subgroup and taking one or more group. So when you read the meaning of sampling, you can answer this one. The answer will be 2. That is 2. Next, very important, sampling and non-sampling error. Read out what do you mean by sampling error and what do you mean by sampling non-sampling. If you read this one, this material, that is enough. You can no need to refer other material. Read this material for understanding of sampling and non-sampling error. And there are a statistical estimation, point estimation and interval estimation will be there, and its characteristics. And hypothesis testing, you know that what do you mean by hypothesis testing? Hypothesis testing is nothing but assumption or guess, pre-assumption. We make a pre-assumption about the uh, research, so that is called hypothesis. In hypothesis there are two types of hypothesis: null hypothesis and alternative hypothesis. And there will be two types of error. Type 1 error and type 2 error. Type 1 error is nothing but probability of rejecting null hypothesis when it is true. Is type 1 error. Type 2 error is probability of accepting null hypothesis when it is false. It is also denoted by beta. So read, very important, type 1 error and type 2 error. You can expect some question. And this also very important. Significance level denotes by alpha, confidence level denoted by 1 minus a, and critical value separate critical region from the acceptance region. You should know the how to accept and how to reject the hypothesis, what are the criteria, and what are the significance of the criteria. So that is very important. And this one also very important, power of test 1 minus beta. Power of test as represented in 1 minus beta. And one tail test, two tail test. What do you mean by one tail test? If the hypothesis is one directional hypotheses are there, so that means one tail test. So for example, greater than or less than, so that is one tail test. If the direction, if the hypothesis is non-directional, means equal, so that means two tail test. So this concept is very, very simple. If you read once, one time, if you read, you'll understand. Identify the following step would include hypothesis testing. First, state the null hypothesis and alternative hypothesis, correct. Set the significance level before the research study, correct. Estimate all outliers. Or this is not the steps involved in the testing of hypothesis, so that is wrong. Obtain the probability value using computer programs such as SPSS, correct. Compare the probability value to the significance level and make the statistical decision, correct. So except C, all answers are correct. So that means A, B, D, E, A, B, D, E. So answer C. You read out this one. And in statistical test, we have two types of test: parametric test and non-parametric test. Parametric test means when the assumption of distribution, normal distribution, is meant. So that is called a parametric test. And we know the parameter. The parameter, when we know the parameter of the population, we apply parametric test. When we do not know the assumption of distribution. Yes, any doubt? Any doubt? Please mute your audio. Okay. So there are two types of statistical tools: parametric test and non-parametric test. Parametric test means if the data is normally distributed and we completely know the parameters of the population, then we apply parametric test. So here you should know what are the what are the parametric test and what are the non-parametric test, and how to calculate the parametric test. Everything. First one, Z test. So Z test is given by the Fisher, which used to compare means when population standard deviation is known, sample size is large based on normal probability distribution. So when the population standard deviation is known, this is a parametric test. So and sample size greater than 30, range of Z statistics is given plus or minus to infinite. Assumption, independent observation, follow normal distribution, random sample, homogeneity of variance. So applicable to all parametric test. See, assumption is very important. You have to remember what are the assumption of parametric and non-parametric, and again what are the assumption of each test. So here the assumption of Z test, independent observation, follow normal distribution, random sample, homogeneity will be there, and applicable for all parametric tests. And application, the formula for to find out Z test is equal to x minus mu divided by standard deviation. Mu is nothing but population mean, and if there are two sample size, the formula is different. Next, t-test, introduced by Gossett, comparing means of sample used. T-test are used to compare mean between one sample, two sample. There are again in t-test also there are different types of t-test are there. Independent sample t-test, paired sample t-test, one sample t-test. So you read that and for identify the formula and application of the t-test. So in test, first thing meaning, when it will be applicable, and what are the assumption, and what is the formula. So these three things you have to remember in test. Based on that, they can ask question. Then F test, you know that F statistics simply a ratio of two variance, two normal distribution of the variance or not. So normally used. And ANOVA is very important. In ANOVA, we have two types: one way ANOVA and two way ANOVA. You should know the calculation, simple calculation. You can expect some question from ANOVA. Next, chi-square test. Chi-square test, you know that very important test. It will be used to test the independence of attributes, test homogeneity, test of goodness of it, and test comparing variance. So sometimes they will ask whether chi-square test, parametric test or non-parametric test. The chi-square test has both parametric and non-parametric. It has both application, parametric as well as non-parametric. Man-Whitney test and Kruskal-Wallis Hedge test. This is non-parametric test. Man-Whitney test. It is a substitute for independent sample t-test. Each For each parametric test, there is a substitute for a substitute is there for non-parametric test. So Mann-Whitney test and Kruskal Wallis H test. So read why it is used and what is the formula to find out that. And next one. So there is question. A researcher wants to test the significance of difference between the average performance of two sample sized samples when the information of the population standard deviation is not available. Which one of the following hypothesis testing is suitable used? So compare the mean. To compare the mean between two samples, we use t-test. So answer will be t-test. If your score in an exam is 80 with the mean of 60, what would be standardized score for this mean? In the standard deviation is 15, so it requires some calculation. So I'll share the material. If I have the board, I'll do that. So these are the question you can expect from the uh, statistics. Thank you. 10 minutes are there. If you have any question, you can ask. I'll share the material, don't worry. Any questions? Madhura ma'am, are you there?
Sir. Yes, sir.
I completed. Finish it off.
Yes. Participants, if you have any questions, you can raise.
Hello.
Yes, tell me.
Hello.
Ma'am.
Sir, could you send me material for the same regarding the questions on kurtosis, cueness, parametric and non-parametric test in case if you have, sir. It's just a request.
Questions, you want questions? Hello, you
Yes,
want
sir, about the questions. A few questions, you had just put it on the screen, no, sir. Two questions on kurtosis, I think one question on skewness and one question on, could you please share the material if you
I'll
have?
share the material. I'll share the
Yeah,
material.
yeah,
I'll
sure.
share the videos. Okay.
Yeah, you were specifying something about a channel, video channel in the beginning.
Yeah, ever
Um,
study class. I referred ever study class. They also have the material, study material. You can purchase the study material. That is for each subject. They have separate material, and question answer will be there. They will collect all the question papers from the different state, KSET and net question papers and solve it. So that is the best material. I'll suggest best material for net and
you mean
JROF.
to say everstudy.com only?
Everstudy.com.
Thank you so much, sir.
Thank you.
Any other queries from the participant side?
Okay. I hope there is no question. I I want to tell you all the best for your net exams. Do well. And one more for the last minutes, today 15, I think 18th exam. In our study class, there is one playlist, 5 minutes session, 5 minutes session. That means they cover each topic in 5 minutes. There are 100 videos are there. So in last minute, it is best. I think I'll advise go through that videos 5 minutes video. They'll cover each unit in 5 minutes. Very simple and crisp. Go through that.
Okay, thank you, sir, for your dedicating your time and expertise to our UGC NET Crash Course 2024. Your session has not only enhanced our knowledge of statistics, but has also motivated us to strive for excellence in our academic endeavors. On behalf of Enrefine and Yasim, I extend a heartfelt thanks to you, sir.
Thank you. Thank you all.
Yes. Participants, please note there will be a break now. Next session will start at 11:30. I kindly request you to join at 11:25. Be on time, participant, please. I hope all of you can able to hear me. Yes? Kindly. Yes. Thank you. So our next session will start at 11:30. So resource person will be there before 5 minutes. So I kindly request we join at 11:25.